All right, about to do our notes and present the screen. There we go. All right, so last week we did Lewis dot structures for ionic compounds. Now we need to do molecular. Now I think I hinted to this, but ionic is easier. We've already done that. We started with the easy one. Molecular is a little more difficult, but you really do just have to follow a list of rules. If you follow those steps, you always make the right shape. Okay? So for a Lewis dot structure for moleculars, remember what molecular means. Molecular compounds are non-metals only. So they are things that bond. If I'm drawing a little mock periodic table over here, they are only over here. That is it. Just the stuff in the corner, if they are found over there and they make a compound together, then that is a molecular covalent bond. Now, things over here like to make negative charges. They like to gain electrons to get to a stable configuration of having 8 valence electrons, 8 electrons on the outside. They all want to gain. So being that when they make bonds together, neither one of them wants to give the other atom an electron because neither one of them wants to lose one. They all want to gain. So they're not going to lose an electron like ionic does, lose one, the other one take it and become positive and negative and then stick together with positive negative attraction. They don't do that. What they do is they share electrons. Okay, they're going to share their electrons till they each have a stable octet. So they each are sharing enough that they have 8 most of the time. The molecular compounds bonds are made of 2 electrons. So how their bonds are made, they're made of 2 electrons. And they are represented in our Lewis dot structure. How we're going to draw it, how we're going to show that there's 2 electrons being shared is by a line. So every line that you draw represents 1 electron being shared from one atom, another electron from the other atom being shared. So 2 electrons being shared. Okay, let's scroll down. You can kind of see, well, actually I guess I'll go with this. So in our little pictures, there could be single bonds, double bonds, or triple bonds. So a single bond, again, represents 2 electrons. We just draw a line. So these hydrogens are this hydrogen sharing 1 electron and this sharing, this hydrogen sharing an electron. And then we draw that as just 1 line, saying they're both sharing an electron, and that's how they are bonded together, is that share bond. Sometimes atoms need to share more than 1 electron each to become stable. So as for an example, when 2 oxygens meet, they don't have enough valence electrons to just do it with 1 single bond. So this oxygen had to share 2, and this oxygen had to share 2. In that case, they had 2 of their own, 2 of their own, so that's 2, 4. And then they're sharing 5, 6, and then they're getting from the other side 7, 8. So with sharing, they have 8 electrons on the outside. Same thing, the other one has 2, 4, 6, 8. So they have 8 being shared. So each of them overall have access to 8 electrons on the outside. So it looks like that at the end. And then there's a triple bond that is not used that much, but sometimes it's also still needed to make it stable. So in this case, when these nitrogens bonded together, both nitrogens only have 5 electrons on the outside. They're in the 5th column, and we have 5 valence electrons. They only have 5 that they could possibly share. So in this case, this one has 1 of its own, so 1 pair, so that's 2, and then it shares 3, 4, 5, and gets from the other nitrogen 6, 7, 8, that's 8. Okay, so in that column, they have 8 by themselves, same thing. This one has 2 of its own, and then shares those 6, so then has 8. So they have 8 to share. It's not that they have 8 by themselves, it's just that when it's said and done, they have 8 that they could be sharing, so they have 8 part of the time. All right, we're going to scroll down and see, like, how do I make those shapes? So, like, I guess I have singles and I have doubles and I have triple bonds, but how do I know when to use what? How do I do it? And you actually just follow these steps. That's it. You have step 1 through step 7. You follow it, you do what it says, you get your shape. Okay? So I'm gonna, I wish I had this in a way that I could make it, you see it at the same time. Not that. I guess we'll just start with 1 and I'll have to scroll down, which will be annoying, but is what it is. It doesn't fit on one screen. Okay, so step 1 says add up the valence electrons for all the elements that we're saying are going to bond in a compound. So in this example, example 1 over here, we have NCl3. I know it might be a little hard. Cl3 to see this example. That's what it is. So I have 1 nitrogen and I have 3 chlorines. So this example, I have 1 times 5 because every nitrogen has 5 valence electrons. So that's just 5 electrons total. Then I have 3 chlorines. So every chlorine has 7. All of them have 7 valence electrons and there's 3 of them. So 3 times 7 is 21. So now when I add those up, 5 from the nitrogens, 21 from the 3 chlorines, I get 26 total valence electrons. All of those valence electrons have to be accounted for in your Lewis dot diagram because they have 26 valence electrons when they make this bond. Okay, step 2. Divide by 2 to get the pairs of electrons. Now, I feel like you don't really have to do this step, but it might help you do this step, so we'll go ahead and do it. I'm going to divide by 2. So I had 26. I divide by 2, so I have 13 pairs. So when I'm drawing these Lewis dot diagrams, they are always drawn in pairs. They're not single dots. They are drawn in pairs. So I will have 13 pairs to put somewhere. Okay, step 3. Arrange the atoms with C or the single atom, so the atom is by itself, or if carbon is an option, it always likes to go in the middle. So you're going to pick the atom that's going to go in the middle of this drawing. If carbon is an option, it always goes in the middle. It loves to be in the middle. If carbon is not an option in this specific compound, then whatever atom you only have 1 of. So you have a single of that. That's the one that's going to go in the middle. Okay. So in this example here, it says arrange the atoms, carbon, single atom. So it's the same thing I just said. So we have NCl3, right? So I don't have a carbon. So then I put the single atom in the middle. This is the one I have 1 of is nitrogen. So nitrogen went in the middle, as you can see here. And then I just put the other 3 around it, chlorine, chlorine, chlorine. Now I could have put this chlorine on top. That would have been fine. That's not wrong. You just put 1 on each side, kind of pretending like there are 4 sides generally. Sometimes there's more on it, but we're going to stick to ones that generally just have up to 4. Okay, so that step is done. Now step 4, draw a single bond between the central atom and each of the outside atoms. And then subtract the electrons used. Remember, every line I draw is actually, it means 2 electrons that are being shared, okay? So in between that nitrogen and the chlorines, I drew a single bond in between each of them, saying that this nitrogen was sharing and this chlorine was sharing. This nitrogen was sharing, this chlorine was sharing. This nitrogen was sharing and this chlorine was sharing. So they're all sharing at least 1 electron. Now, each of those bonds is worth 2 electrons. That's 2, 4, 6. I've used 6 electrons up in that pair. So either you could say I had 26 to start and I subtract 6. So now I have 20 left. Or you can go by pairs because everything is in pairs. So you have 13 pairs and I used 1, 2, 3 pairs and now I have 10 pairs left. I don't care which way you do it. I was always taught to just go by the actual number, but if pairs makes more sense to you, then that's fine. All right, next one says step 5. Add electron pairs to the outside atoms until they are happy, meaning they have 8, or if it's helium or hydrogen, they have 2. Well, actually, helium won't want. So if it's hydrogen, if they will have 2, everything else needs to have 8, but hydrogen only has to have 2. Actually, it can only have 2. Subtract electron pairs added from the total that you used, okay? So around this circle here, see that I'm going to add electrons to the outside atom first, all the chlorines, and they want 8. So I have how many pairs left? 10, or I have 20 total electrons left. So I'm using 2, 4, 6, and then it's sharing this one, so that's 8, 2, 4, 6, 8. And this chlorine needs 2, 4, 6, and it's sharing the 8. And this chlorine needs 2, 4, 6, and it's sharing the 8. So how many pairs did I just add? I added 3 around this chlorine, 3 around this chlorine, 3 around this chlorine. That's 3, 6, 9. I've used 9 of my pairs. I only have 1 pair of electrons left to use. Okay, so then I go to step 6. Step 6 says add all remaining electron pairs to the central atom. So if you have any electrons left, which we do, we have 1 pair left or we have 2 electrons left. And that just gets tacked on to the center, however many you have. So like you can see here, those 2 dots just get tacked on to nitrogen, dot, dot. And then I had the 1 pair left. Well, I used it, so now I'm out of electrons. I've used all valence electrons up. Okay, the very last step is just to make sure that it's happy or not. Did we finish? Are we done? So that step 7 is just to make sure you're finished, because sometimes you're not. Sometimes it doesn't make them all have 8. So look at step 7, it says check to see if the central atom is happy. So in this case, does nitrogen have 8? It has 2 here, then 3, 4, then 5, 6, and 7, 8. So yes, nitrogen is happy. Yes. If central atom is happy with no electron pairs left, then you stop. If I check and nitrogen was not happy, that's when I would add that double bond or the triple bond, which we will see those in an example later. In this case, it's not. All the chlorines have 8, nitrogen is sharing 8, so we're good to go. It's done. All right. So now I just want us to practice that more times, okay? So I'm going to go through the whole process with a new one. Carbon dioxide. Here we go. So carbon has 4 valence electrons. Again, how am I getting this number? Is you go to your periodic table, right? Okay, and we wrote 1, 2. Then we had 3, 4, 5, 6, 7, 8, and barely fits. But if they're in those columns, we wrote those last week. It's above the column. It says either 1, 2, and then you skip the transition metals. We always skip this area. And then it has 13, 14, 15, 16, 17, 18, but it's really 1, 2, 3, 4, 5, 6, 7, 8. That's how many valence electrons I have. Okay, so carbon is in this column. So that's 4. I only have 1 of them, so it's just 4. Then I add oxygens. Well, there's 2 oxygens, so it's going to be 2 times however many oxygen has, which oxygen is in the 6th column, so it has 6. So it's going to be 4 plus 2 times 6, which is 12. So 4 plus 12 is 18, right? No, it's 16. It's 16. Woo, my bad. Okay. So it's got 16 valence electrons, and I have to use them all up. So I'm going to go ahead and do this way. So I'm going to use just the actual number, not pairs this time, just so you can see the difference. So I have 16 total valence electrons. All of them have to be used. All right, next rule. So I counted my valence electrons always first. Step 2, divide into pairs. I said I'm going to skip that one just for now. Step 3, arrange the atoms. If there's carbon, put it in the middle. If there isn't a carbon, whatever you have 1 of is what goes in the middle. So in this case, I do have carbon. I have CO2. I have carbon in the middle, and I'm going to singly bond it to the only other things I have, which is 2 oxygens. Now remember, each bond is technically 2 electrons. So I've used 1, 2, 3, 4. I've used 4 of my 16. I have 12 valence electrons left. You always want to keep track of it to make sure you're doing it right. So I have 12 left. Okay, next rule. Says, draw a single bond between the central atom and each atom. Oh, I did that. Okay, did it. All right, I kind of put those 2 together, sorry. Then step 5, add electron pairs to the outside atoms until they are happy. Okay, so I'm going to do the outside atoms first, which is the oxygens. I have 12 left. This oxygen already has 1, 2, so it needs 3, 4, 5, 6, 7, 8. Now it has 8. I've used 6 of them. Okay, I have 6 valence electrons left. I still need to make the other oxygen happy. So it already has 1, 2. Then I get 3, 4, 5, 6, 7, 8. Now that oxygen has 8, I've used my last 6 valence electrons. I'm out of electrons. Okay, I'm out. So then when I go over here, it says add electron pairs to the outside. Did it. Add all remaining electrons to the central. I don't have any remaining. So I don't do that. I don't have anything left. Step 7, check to see if the central atom is happy. Okay. Does carbon, the central atom, have 8? It has access to 1, 2, 3, 4. So no, it only has 4 right now. So it's not happy. Doesn't have 8. So I need to follow this column. If it's not happy, then move pairs of electrons from the outside atoms into double or triple bonds until you have a stable octet in the middle. Have 8. So I'm going to steal this pair and make it share. I'm going to steal this pair and make them share. Now, how many does carbon have? He has access to 1, 2, 3, 4, 5, 6, 7, 8. Now carbon has 8, and oxygen still has access to that, even though we made them share. So these oxygens still have 1, 2, 3, 4, 5, 6, 7, 8. So let's redraw it, because now it looks crazy. So they ended up being double bonded to the oxygen to make them have an octet. And these oxygens still have 2 pairs of valence electrons of their own. Okay, so that's done. Good. Scrolling down, scrolling down. Okay, so now for water, again, same thing. I'm just going to do the same process. Hydrogen has 1, but it'd be 2 times 1 because there's 2 of them, H2O. Plus the 6 that oxygen has, so that would be 8 total. I only have 8 valence electrons in this example. Now for my valence electrons pairs, let's do it the pair way. So 8 divided by 2 is I have 4 pairs. So I'll go with pair route this time and say I have 4 pairs. Next rule says pick the one that's going to go in the middle. All right, so if I don't have carbon, then it's the one I have 1 of, which is oxygen. Bond it singly to the other things there, which is hydrogen. Okay, there we go. That used 1, 2, 3, 4. Now, I used 4, but how many pairs I used? Just 1 pair, 2 pair. So I've used 2 pairs, so I'm going to subtract those off. I have 2 pairs left. Okay. Next rule says put your valence electrons around your outside atoms till they have 8. But here's a little caveat. Hydrogen, remember, doesn't get 8. It's the only one that only gets 2. So it actually already has 2. Already has it. Don't add any more hydrogen ever. Hydrogen can only have 1 single bond. That's it. Okay, so skip to the next rule. Next rule says put any remaining electrons on the center atom. Well, I still have 2 pairs. So I'm going to put those on my center atom. There we go. I've used all my valence electrons up. So the last rule says check to see that the center atom is stable, that it has 8. So this oxygen has 1, 2, 3, 4, 5, 6, 7, 8. It's good to go, okay? So it actually ends up looking like this vent shape right here, okay? So how do I know what shape it has? When I go over here, I look at atoms bonded to the center. How many atoms are on the center? Well, oxygen, and it has 2 hydrogens on it. So it has 2 atoms bonded to the center. So it's going to be one of those to find out what shape it's called. Then it says how many electron regions are around the center atom. Still, it's always on the center atom. So I have this one around it, and this one around it. So it has 2. So it has 2 on the center. Oh, electron regions. I'm doing this wrong. That's not what it's supposed to say. Electron regions is everything that's attached to it. So it has 2 lone pairs, and it has 2 atoms. So that is 4 electron regions, 4 total things on it. So it's bent, which it looks like the shape I drew. It has the 2 lone pairs, has the 2 attached to it. So this shape is bent. Okay? Now I'm gonna have to stop because the bell rang. I will record the other 2 if you need more help. That might be enough for you to be able to do your assignment. If it's not, well, actually, you're gonna have to fill in your notes. So I will post this during 8th period, and I'll even open a Google Meet if you just wanna do it with us. I just sadly ran out of time, darn it. Okay. All right, I'm gonna finish where I left off. So again, you just start with rule number 1, which is counting your valence electrons. Remember, carbon is in the 4th column, so it has 4. Chlorine is in the 7th column, so it has 7, but there's 4 of them. So I'm gonna have 4 times 7. I'll add those up. So 4 times 7 is 28. 28 plus 4 is 32. So I have 32 total valence electrons, and all of them I have to use. Now, again, I'll break it down into pairs. So 32 divided by 2 would be 16. So I have 16 pairs. That's what we'll start with. 16 pairs of electrons. Second rule says pick the one that's going to go in the middle. If carbon is an option, it's carbon. If carbon isn't an option, then just whatever atom is single. In this case, carbon is an option. So I'm going to put carbon in the middle. I'm going to put everything else around it. So I have 4 chlorines. I'll put all the way around. Then it says to connect them with a single bond. So I'm going to connect each of those with a single bond. Remember, each single bond is 2 electrons, but 1 pair. So how many pairs have I used? It would be 1, 2, 3, 4. I've used 4 pairs out of my 16. So I have 12 pairs left to use. Next rule says to put the electron pairs around the outside atoms until they have 8. So go ahead and do that. So I have 2, 4, 6. Remember, it's sharing the 8, so that one's done. And then I have 2, 4, 6, sharing the 8. So far, I've used 1, 2, 3, 4, 5, 6. I've used 6 pairs. Just turn it on. And then you have 6 pairs left. So I'll put these on the other 2 outside chlorines. So 1, 2, 3, 4, 5, 6, sharing the 7, 8. And lastly, 1, 2, 3, 4, 5, 6, sharing the 7, 8. And again, that was 1, 2, 3, 4, 5, 6 pairs. So I had 6 pairs left, and I used 6 pairs, so I'm out. I'm out of valence electron. The next rule says to make sure, no, actually it says if you have any leftovers, put them on the center. I don't have any leftovers, so no more from the center. Lastly, just check to make sure your central atom is happy that it has 8. So it is sharing 1, 2, sharing 3, 4, 5, 6, 7, 8. So it has 8, so it's it. Now, when you try to find its name, again, you're going to look over off to the side and just say how many atoms are bonded to the central. In this case, there's 4. The only one that has 4 that you're going to have to know is a tetrahedral. So that's what it's called. The shape is called a tetrahedral shape. Later, actually, right after Thanksgiving, you're going to learn that tetra means 4. So that makes sense. It has 4 atoms bonded to the central, and it's called a tetrahedral. All right, last one. All right, last one is 1 chlorine and 3 oxygens. Chlorine has 7 valence electrons. Oxygen has 6, but there's 3 of them. So 3 times 6. 3 times 6 is 18. 18 plus 7, I don't know. 20, 25. Yeah. But it says it's negative. So what happens when something is negative is it gains an electron. I mean, the gain is how many it's negative. It's negative by 1, so it gained 1 electron. So I had 25. We always want even numbers, because they're always in pairs. But this other one is negative. It really has 26 valence electrons. So this time I'm not going to do pairs. Just kind of show you the difference. It has 26 total valence electrons. Next rule says pick the one that's going to go in the middle, either carbon or whatever one you have 1 of. In that case is chlorine. So chlorine is going to go in the middle. I'm going to bond it with a single bond to everything else that is there, which is 3 oxygens. So 1, 2, 3. And then subtract off the electrons I've used, which is 1, 2, 3, 4, 5, 6. So out of my 26 I have, I used 6 of them. I have 20 valence electrons left. Next rule says to put electrons on the outside atoms until they have 8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I've used 18 of my 20. I have 2 valence electrons left. Next rule says if you have any left, put them on the central atom. So I'm going to put those 2 on the central atom. Last rule says make sure that your central atom is happy. If not, you'll have to make double, triple bonds. So let's check. Chlorine has 1, 2, 3, 4, 5, 6, 7, 8. So chlorine has 8. So that is the done shape. So now to figure out what it is called, scroll up. How many atoms are bonded to the central is 1, 2, 3. So it's going to be one of these 2. And then it says how many electron regions is there. So there's the 3 from the 3 atoms, so 1, 2, 3. But it also has a lone pair. So there's 4 electron regions. So that makes it a trigonal pyramidal shape. Scroll down, write that one. It's a trigonal pyramidal shape. All right, done we go.